All right, this is proof practice for your test on Monday. These are properties of quadrilaterals, but it's only covering parallelograms and special parallelograms. It is not covering kites and trapezoids. That's a separate slide on your notes, on your module for the chapter. So it has all the properties for all the quadrilaterals. Keep in mind you have to remember that. So please make sure you guys are writing down these properties because you have to know the properties and what makes up what. So first I'm going to do properties of a quadrilateral, specific things that you have to know that make up a quadrilateral is that a quadrilateral has 4 sides. Okay, quadrilateral has 4 sides and all angles sum to 360. Okay, all your angles added together equal 360, and that's for both interior and exterior. Okay, so please make sure you know what makes up a quadrilateral. All right, properties of a parallelogram. There are a few properties of parallelograms. Okay, so let's go ahead and write them down. There are 5 that I'm going to write. The first one is that all sides, or not all sides, let me take that back, opposite sides. So it's not all, it's opposite sides are congruent, and opposite angles are also congruent. Another thing you need to know is that opposite sides are parallel. Okay, please don't forget that. Your opposite sides are parallel. Another thing we have to know about parallelograms is that your diagonals bisect each other. Diagonals bisect each other. And consecutive angles are supplementary. Okay, so that is properties of a parallelogram. So we have to know the properties for my parallelograms. All right, I'm going to go ahead and look at rhombuses. So go ahead and zoom into properties of a rhombus. Properties for a rhombus, I have 4 sides, okay, 4 congruent sides. You have 4 congruent sides. You also have diagonals intersect at a 90-degree angle. So your diagonals are perpendicular. Okay, that's 90 degrees. And then your diagonals bisect opposite angles. Okay, and I'm just going to draw the diagram for you so you could see what it looks like. You don't have to draw it because it is in your notes, but just so you have it on this same page, here are my diagonals. They intersect at a 90-degree angle. All 4 sides are congruent. And then my diagonals bisect my angles. Okay, they bisect the opposite angles. So I'm showing you what's congruent for my angles. I'm going to go ahead and go over to properties of a rectangle. Rectangles are pretty easy. So the first one is that rectangles have 4 right angles. And another one that we have to know is that our diagonals are congruent. So again, I'm going to draw a rectangle. Your diagonals are congruent. And you have 4 right angles. All right, looking at my next one, I have my square. Looking at squares, key ones that we should know, hopefully already know, is that you have 4 congruent sides and you have 4 right angles. Okay, there are plenty for squares. So when I'm looking at this one, what else do I know? I know squares have the properties of rhombuses. Squares also have the properties of rectangles, and they also have the properties for parallelograms. Okay, rhombus also has the properties of parallelograms as well as my rectangles. Please keep in mind. Squares are rhombuses and rectangles. However, rhombuses and rectangles are not all squares. Okay, some rhombuses can be squares, some rectangles can be squares. So please understand that. So you guys had those questions on the homework with the sometimes, always, never. Please make sure you review that. All right, looking at our first proof, we should know the setup for proofs. Go ahead and draw your T-charts, your sometime statements and reasons. So let me zoom out a little. I have my statements. And I have my reasons. And looking at it, the first thing they gave me was A, B, C, D, E, B, G, F, and H, J, K, D are parallelograms. So that's the first thing they're giving me. So I'm going to put that in my statements first. So A, B, C, D, E, B, C, F, and H, J, K, D are parallelograms. And my reason for that is given. Okay, I'm going to highlight all of my parallelograms. Keep in mind, it's telling me they are parallelograms, so I'm not going to have converse here. There are no converses because it says it is a parallelogram. Okay, it is a parallelogram. Then blank. So they're telling me it's a parallelogram, so I don't have converse. Please pay attention to that when we're going over these. So what are they giving me? What do I have? I have triangle, or sorry, not triangle, parallelogram ABCD. I also have EBGF, and I have HJKD. We're trying to prove that angle 2 is congruent to angle 3. Who could give me an idea, or what do they think I can prove here? What can I show that's congruent? What can I do in order to help me prove that angle 2 is congruent to angle 3, Jonah?
E is congruent to B.
Okay, so my angles are congruent. What would that be considered? What would that be called if I were to put a reason?
Opposite angle.
Good. Opposite angle, okay? I am going to use, for my second one, I'm going to do it in purple. I am now using parallelogram, opposite angles theorem. So which angles are congruent? You told me. We'll say angle 4 and angle 1. What else is congruent? Angle 4 is congruent to angle 1. What else? What other angles are congruent using opposite angles theorem? Yeah.
1 and 2 and 4 and 3.
Okay, 1 and 2 is congruent together. So angle 1 is congruent to angle 2. And then my last one, yes, is angle 4 is congruent to angle 3. Again, keep in mind what you're trying to prove. You're trying to prove that angle 2 is congruent to angle 3. There's a lot of stuff that are congruent here. How can I prove that? What can I do? Looking at what I have, what can I say is congruent? Jonah?
You can substitute.
I'm going to substitute. Yes, I'm going to go ahead and I'm going to substitute. Pay attention to how I'm substituting because there's a specific way to substitute for these. I cannot just automatically say angle 2 is congruent to angle 3. I have to do it in steps. So look at what's given. Okay, not given to us, but look at what we found. What did you say I'm going to substitute first, Jonah?
You can substitute 4 for 3.
Okay, I'm going to substitute 4 for 3. Pay attention to how I'm substituting. I am going to end up with angle 1 is congruent to angle 3. I'm going to show you how we got there. I'm going to put it in gray. How I'm looking at it is I have angle 1 is congruent to angle 4. And then I have angle 4 is congruent to angle 3. Look at what's happening. I'm getting rid of that overlap. I'm getting rid of this overlap right here. And that's called substitution. Yes, if you want to put transitive, that's fine, but please be aware. Sometimes most of the time, if it's transitive, it's always going to be substitution, but sometimes it's not going to be transitive, it'll be substitution. Hopefully that makes sense. So I highly suggest instead of using transitive all the time, use substitution because you're substituting something. Yes, I'm getting rid of the overlap for transitive, but I suggest always use substitution. And then my next one, I can go ahead and write it as step 4. Angle 2 is congruent to angle 3. So I eventually got there. How did I get there? I have angle 1, or I'll put it this way. Angle 2 is congruent to angle 1. And then from number 3, I have angle 1 is congruent to angle 3. And I'm getting rid of, again, that overlap, or again, I'm substituting it. So for this is substitution.
So would we need to write the part that's in gray?
Would we what? No, I am just visually showing you that you can't just get there, and you can't just automatically put angle 2 to angle 3, because if you're putting angle 2 to angle 3, if you're looking at these, you can't substitute anything from 2 to 3. You have to do it in steps. Okay? Any questions on the first proof? All right, looking at my second proof. Writing my 2 columns again. I have my statements and my reasons. And yes, just giving you a heads up, they want us to prove that it is a parallelogram. So I will be using converse here. I will be using some sort of converse here. As well as you do have to know information from previous chapters. So really pay attention to this one because a lot of students were confused and then I clarified how we got to where we got. All right, looking at it. Going ahead and writing my first one. They gave me angle B is congruent to angle D, which is also congruent to BCE, and it is drawn on our diagram. They did give it to us on our diagram. So now looking at it, they want us to prove that it's a parallelogram. Again, you have to remember properties of a parallelogram. What makes a parallelogram a parallelogram? There were multiple theorems. So looking at it, what can I find first? What can I do here? What do I have? Looking at it, thinking about it. What do I have here? Yeah.
Can you prove that these are parallel using alternate?
Good. Yes. So I have alternate angles. Where are my alternate angles? Right here. Yes. I can then prove that something is parallel. Keep in mind, if we go back to previous chapters, we had if parallel lines were cut by a transversal, then you have alternate interior angles. That was alternate interior angles theorem. But now I'm looking at it backwards. If I have alternate interior angles, then parallel lines are cut by a transversal. So now I'm looking at the converse of it. Okay, so I'm going to just highlight that one so you could see where I'm finding that information. These are my parallel lines. How do I know they're parallel? Because I have alternate interior angles. So for this one, for 2, it's going to be A, B is parallel to DC because alternate interior angles converse. All right, so right now I have parallel lines. What else do I have here? Yeah.
Since they're parallel lines now, can you prove that these two are corresponding to these two?
Okay, so yeah, I have corresponding angles as well. So if you forgot what corresponding angles are, corresponding angles, I'm just going to write it over here, is when you still have parallel lines cut by a transversal. These are considered corresponding angles. So if you're looking at the diagram, we also have corresponding angles. I'm going to highlight it for you. Here are my corresponding angles. So that means these are parallel lines cut by a transversal to give me corresponding angles. So now I can go ahead and state for 3, AD is parallel to BC by corresponding angles converse. Could you switch the order for 2 and 3? Yes, you can. If you saw corresponding angles first, that's fine. And then you would have to show me the alternate angles converse. So drawing my arrows. And look at what I have. How can I prove? What is the last thing that I should write? How do I know that it's a parallelogram? Okay. What? What was that? Yes. It would be A, B, C, D is a parallelogram. Yes, if you want to draw it, that's fine. By definition of a parallelogram. Okay, so yes, by definition of a parallelogram, you have opposite sides that are congruent. No, opposite sides that are parallel. Okay, 2 pairs of opposite sides that are parallel. So please do not forget that. All right, looking at the next proof, they're giving me information. Go ahead and draw, if you have not already done so, your 2-column chart. Do you have your statements and your reasons? Okay, and then we have AD is congruent to CB and it's drawn for us. And then angle CBD is congruent to angle ADB. And all of that is given. So same thing, they're asking me to prove that it's a parallelogram. So for this one, I will be using something with converse. Okay, so looking at it, what can I prove here? What do I have? Looking at my diagram, what do I have? What can I use? Anyone see anything that they can use? Okay. Looking at it, I can see that I have alternate angles. Okay, so they're kind of giving me my transversal. If I'm looking at it that way, they're giving me alternate angles. Again, you have to remember what makes a parallelogram a parallelogram, you have to remember those theorems. So, looking at this one, pay attention to this because a lot of students get confused on this. If I'm looking at my diagram, here is my transversal. I have alternate angles. I want to find my sides that are parallel. So, if I make these sides parallel, and I draw my transversal, these are not alternating angles. Why? Because it's not going all the way to the end. It's not going all the way down. So AB is not parallel to DC. I do not know that. I cannot write that. Now, let me go ahead and check the other ones. So let me erase this. So let's go and look at the second one. Let's say I'm going to change those parallel sides. You have to understand the difference when you're looking at these. If I drew my parallel sides right here, cut by a transversal, are they now my alternating interior angles? Yes. So you have to be aware of where the angles are according to the parallel lines. So for this one, I am going to have parallel lines. Where are my parallel lines? I'm going to have AD and CB. So AD is parallel to CB by alternate interior angles converse. I'm looking at the converse of the angles. So looking at it, I'm making these parallel. Who can tell me, how can I prove that this is a parallelogram? How could I prove that it's a parallelogram? Jonah?
By the opposite sides parallel and congruent theorem.
Good. You have to remember your theorems, guys. So looking at it, yes. This is opposite sides, parallel and congruent. If you're looking at it, my sides are parallel and my sides are congruent. Keep in mind, it's one pair. It's one pair of opposite sides, and that is one pair. So the last one would be 3AB CD is a parallelogram. And my reason is going to be opposite sides, parallel, and congruent theorem. Okay, so again, you have to remember your theorems. Looking at the next slide, these are some theorems for parallelograms. Keep in mind there is a Quizlet on Canvas. I will put it, it is up there, but I'm going to put it at the bottom just so you have it for the review. This is also what makes a parallelogram a parallelogram. Okay, so we used for this one, you have the definition of a parallelogram. Okay, opposite sides are parallel. You have opposite sides, converse. These are the converse. Okay, you have parallelogram, opposite sides, parallelogram, opposite angles. Those are both converse right here. Okay, parallel and congruent theorem, and then diagonals converse. So again, you have to know what all of those are. And then here is a flow chart for all quadrilaterals. This is also on Canvas at the bottom. You could look at it, just this slide. But yes, you have to know the properties, what make up what. And again, you have to remember your theorems. Here's another kind of flow chart. This one's a hierarchy of special parallelograms. These are just the special parallelograms. The other one had kites and trapezoids. Okay, and you have a little graphic organizer with everything on it for all of them. So you guys have more than enough information to use to help you study.